Alright, in this video we're going to look at curve sketching. Now what curve sketching is basically taking a function and graphing it without actually putting it into a calculator. So you can use this to actually see what a graph would roughly look like without using a calculator. Now there are certain steps that you need to do to actually find or plot this graph. First, you have to find the zeros. Second thing is to find the vertical and horizontal asymptotes. Then 3, which also connects with 1, is find the y-intercept and then plot it as well. 4 is to find the intervals by plotting them on a table. To determine increasing or decreasing values, as well as if it's concave up or down. Yeah. So let's take a function and use these steps to sketch a graph. Okay, let's see. I have a function here. Question asks to graph y equals x squared minus 1 over x squared plus 1. Okay, first we need to do is find the zeros. Now to find the x and y intercepts, we're gonna let y equal 0 for one and x equal 0 for the other one. For y intercept, we're gonna let x equal 0. So we have both 1 and 0. We also have negative 1 and 0. Now for y equals 0. Oh fuck, I messed it up.
No man, you got it. Keep going.
Zombie attack. Now
set y equal to 0.
This should be y, this should be x.
No.
That should be y, and that should be x. Alright, for this one, we're going to set x equal to 0. And if we did that, we have negative 1. And that's about it. So these are the points we're going to have on the graph. Now for finding the vertical and the horizontal asymptotes, for the vertical, we have to look at the denominator. And we have to set it equal to 0. That's the only way we can get a vertical asymptote, is if the denominator is 0, undefined. Now we look at this x squared here, and anything we plug in for x, it's always going to be positive. So this will never be true.
What about the square root of negative 1? I'm fucking with you.
So this can never be true. So we don't have vertical asymptote. However, for a horizontal asymptote, we can use the limit definition. As the limit of x goes to infinity, we have x squared minus 1, x squared plus 1. We have x squared, 1 minus x squared, over x squared again, but 1 plus 1 over x squared. Now you can see that it's basically the same thing, so this will eventually cancel and just be 1. So for the horizontal asymptote, we have 1, so y equals 1. Now, we have that part done. Now we need to find the critical values for the graph so we can plot it. So what we have to do is find first derivative. So we're going to use the quotient rule. We have x squared plus 1, x squared minus 1, we're going to take the derivative of that, plus x squared plus 1, we're going to take the derivative of that in this one, times x squared minus 1. And we're going to put that all over the bottom squared, so it's going to be x squared plus 1 squared. We're going to go ahead and jump forward, simplify this. It's going to be 2x to the third power plus 2x minus 2x to the third plus 2x yet again over x squared plus 1 squared. That can be simplified further because you can cancel that and that. So what we have is 4x over x squared plus 1 squared. Now from that, we're going to set it equal to 0 and find critical values. What we find is x equals 0. That's the only thing that will make the top equal 0 and the bottom equal 0. So we're going to take the second derivative to find concave up and concave down. Since we found first derivative, that's going to tell us if it's going to increase or decrease. So for the second derivative, we're going to take the derivative of this. So we have 4x x squared plus 1. We're not taking the derivative of that, we're going to take the derivative of this. Plus 4x x squared plus 1, taking the derivative of that.
Squared.
Thank you. All over to the fourth power. The fourth power, because it was already x squared plus 1 squared, we're just going to multiply by that by 2 since we're squaring it again. We're going to simplify this further, and eventually you will get 4 times 1 minus 3x squared over x squared plus 1 to the third power. Now if we set this equal to 0, we have critical values of plus or minus square root of 1/3. Since we don't have an intervals to go by, we're going to use both positive and negative 1/3. So we're going to go ahead and make a table. So what we have is negative 1/3 square root of negative 1/3, sorry. We have 0 from the first derivative. And we also have positive 1/3. And we'll use another marker so you can see. So basically we have the first function here. The first derivative function and the second derivative function here. So we're going to plug in values that are anything below -1 square root of 1/3. We're going to have a value between negative square root of 1/3 and 0. Same thing here of 0 between 0 and square root of 1/3 and a value higher than square root of 1/3. Now when you plug in these values, you get negative, negative, positive, and positive values. I went ahead and worked these out. Have a negative value here, positive value, another positive, and a negative value. From this we can see that this is decreasing down. This one is decreasing up. This one's increasing up. And this one is increasing down. So what we have are lines that look like that. Now we can take this and graph, after I make some room.
This better count as like 2 videos. My arm's tired.
I'll try to hurry up then.
You're at 12 minutes.
Alright, so we have a graph. Alright, we know that we had a horizontal asymptote of y equals 1, so we have a horizontal asymptote. No vertical asymptote, so we don't need to worry about that. We had, let's see, we had critical points at negative square root of 1/3 and positive square root of 1/3. And we have a turning point at -1. As well as 1 and -1 because of our points that we plotted with the x and y intercept and finding the zeros for each one. So we have 2, 2, so we get a better perspective. So we found out that it first comes down like this, decreasing down. Then we also have decreasing up here. Then we have increasing up like that. And then we have increasing down like that. So each section coordinates with each increasing concavity and decreasing concavity. And that's how you do curve sketching.
Woo!